Hey, welcome back to Math with Patrick. Today is May 12th, and we have problem number 132 from this Daily Epsilon calendar to solve together. All right, R and S are the solutions of this equation. And then once we plug in R and S here, we get Z. And then finally, once we find Z, we can plug it in here, and we're going to get X today. All right, let's just kind of get started. I'm trying to find the solutions to y plus 1 over root y equals 2. I don't really like working with square roots. I'm more familiar with polynomials, and so I'm going to try to change this into a polynomial. I'm going to use some substitution here. I want to use a new variable. I can't use x or y or z. How about a? And if I let y to be equal to, how about a squared? Then I could rewrite this as almost a polynomial, I think. I'll get a squared plus 1 over, and then the square root of y is just going to be a. So 1 over a equals 2. And then here, if I multiply everything by a, I'll finally get a polynomial. I'll get a cubed plus 1 equals 2a. And then usually when I solve polynomials, I like to write them in standard form. And so I'll do a cubed minus 2a plus 1 equals 0. So it's still not easy. Because it's a cubic, I might have 3 different values actually that a could be. And let's just try to find them. I think a equals 1 actually kind of works out. Because if I plug in 1 here, I'll get 1 cubed, which is 1, minus 2 times 1, which is just minus 2, and then plus 1 actually indeed equals 0. So a equals 1 is one of my solutions for this cubic. That's good. I know I could factor this cubic as a minus 1 times some kind of quadratic equals 0. And I suppose I'll use synthetic division to figure out what that quadratic is going to be. So I'll put the root right here. I'll put all the coefficients of my cubic in order. So it's 1, 0, because I'm missing the quadratic term, -2, and then 1. And then with this pattern, I'll just go, or this procedure rather, I'll go down and then multiply and then add, and then multiply and then add, and then multiply and then add. And this 0 right here is my remainder, which is good because I knew that a minus 1 goes into this evenly. These are my coefficients. I'm going to get a squared plus a minus 1. Okay. And then if I solve that quadratic, I'll figure out the 2 other solutions for a today. I guess I'll just use the quadratic formula. So a is equal to -1 plus or minus the square root of 1 minus -4 will be just plus 4 all over 2. And simplifying this, I get 2 solutions. I get a is equal to -1 plus or minus root 5 over 2. And I guess we could translate these values of a back into values of y from before. And I guess I'll just use this equation here. Y is equal to a squared. And I wanted to find the values of y here. So I guess I'll just square my values of a to get values for y. Okay. So if I take this one, literally the number 1, and I plug it into y is equal to a squared, well, y is just going to be equal to 1 squared, which is just 1. So there's one of my solutions. And I'm pretty sure this plus and minus sign just kind of goes away once you square it. Let's just try it both ways and see what happens. So again, y is equal to a squared. So I'll square, how about the positive version? And then I'll also try squaring the negative version, and I'll just see what happens. Actually, I mean, these might produce different values. We'll just see. So squaring the bottom, I'll get over 4 for both of these. And then squaring the numerator, I'll get 1 minus 2 root 5 plus 5 over here. And then this one will be 1 plus 2 root 5 plus 5. Okay, so I guess I am getting two distinct answers. I'll combine my like terms to get a 6 and then a 6 minus over here. And then this one will be a 6 plus. And then I guess since they're all even, I could finally simplify a little bit. And so maybe y is equal to 6 minus 2 root 5 over 4. Or maybe y is equal to 6. Oh, I said simplify. Gosh. Let's divide all of these by 2. So that's going to be a 3 minus root 5 over 2. Or potentially y is equal to 3 plus root 5 over 2. Okay. So these are my potential solutions, but the problem only told me that there was 2, right? There's R and then there's S. So one of these solutions might not work. I mean, if I plug in a 1, right, 1 plus 1 is 2, so that's pretty clear that that one works. So maybe my extraneous solution is coming from the other two. Let's see. Well, I know that, let's see, root 5 is going to be like 2 point something, right? Because like the square root of 4 is 2, so the square root of 5 should be a little bit more than that. So I do still have a positive number here, right? It's 3 minus and then 2 point something. So this is still positive, and this is definitely positive. And so if I look back here, I know I'm allowed to square root positive numbers, so there's no issue there. Oh, but then thinking about like a lower bound here, right? This y value should be greater than 3 plus 2 over 2. Oh, there's a really strong lag there. Okay, back to normal. And this is equal to 5 halves, right, over here. So this number must be bigger than 5 halves, and it's also positive. So once I plug in something like 5 halves, which is like 2.5, and I add some positive number, that's going to be way more than 2. So that second solution is just too big. And I can cross this one out because it doesn't actually solve the original equation at hand. So this is too big. And I'm going to assume here that this is the correct value. So one of these is R and one of these is S. So let me just kind of make a little bit of room here. And maybe we could try plugging those in. Let's just say R is 1. And so Z is going to be equal to R plus S plus root R plus root S. And I said, let's just say R is 1. And then S is going to be the other one, which was, 3 minus root 5 over 2. So that means I will have 1 plus 3 minus root 5 over 2 plus root 1. That's easy. Plus root 3 minus root 5 over 2. Okay, that's kind of hard. I'll combine my like terms. So Z is going to be equal to 2 plus 3 minus root 5 over 2 plus root 3 minus root 5 over 2. And whenever I'm doing these algebra things and I'm like trying to simplify fractions and square roots, I'm going to try my best to like find a common denominator first and then somehow get rid of my square roots if possible. So I feel like I should just get rid of fractions. I see that multiplying everything by 2 might be nice. So I will maintain the value of my number by multiplying by 2 first and then dividing by 2. So I will get 4 plus 3 minus root 5 plus, and then I'll just put that divide by 2 at the bottom for now. When you multiply in a number into a square root, you have to square it. Or in other words, if I multiplied a 4 in here, this is something that could come out as a 2. And so to shove this 2 that I'm multiplying here, I'm trying to distribute it in to the square root. That 2 is going to become a 4. So I'll get 4 times, and then 3 minus root 5 over 2. And I guess I should target this square root a little bit more. Also the 4 plus 3 is just a 7. Minus root 5, still all over 2. And then this divide by 2 and this times 4, I'll just combine together as a times 2. And I'll distribute it as well. So I'll get 6 minus 2 root 5. Still, I don't like this whole square roots and square roots business. And so I want to kind of get rid of it. I'm hoping I can get like the square root of something squared. That way I can just kind of knock them out like that. And I think I actually have a way to do it. This is going to be a kind of strange algebra step. I don't do this often. But let's split the 6 as a 5 and a plus 1 at the end. And here I have a perfect square. I'm going to claim that this is going to be equal to a root 5 plus 1 squared. And I think, oh wait, no, root 5 minus 1, because that middle one is negative. Because if you imagine expanding this back out, we would do first times the first, which is 5. And then we would do the outside terms and twice that. So it'll be twice negative root 5. And then finally, last times last is just a positive 1, which is exactly what I had underneath a square root earlier. So great. We can kind of collect them together as a perfect square. And then finally, I can release that square root because the square and the square root cancel each other out. So I'll just have plus root 5 minus 1 over 2. And hey, look, the root 5s cancel out. So I'm just left with 7 minus 1, which is 6 over 2, which is just 3. Whew. Oh, wait, that's not the answer. 3 is equal to z, right? Yeah, okay. So x is equal to 3 squared plus 3. Wow, which is 9 plus 3, which is 12. What a problem. That's crazy, honestly. Well, hey, x is 12. That's great. And we did it. What an insane problem. I really like this one. The algebra here was so tricky. But I'm glad to say that x is definitely 12, and we're all done. I'll see you tomorrow.